Not equal. So what are the two different inequality signs that are out there in the world? It can either be
positive or negative.
well,
Yeah.
inequalities. Cam?
The
Thanks for trying.
equal mark with a X with a line through it.
That's not equals to would be an option, I guess. So if it's not equals to, what could it be? Equals to, or what else? If it's not equals to, it can either be greater or less than, right? What do the greater than and less than signs look like? Remember in middle school you talked about the alligator. Do they still use alligators? The alligator eating the larger thing.
I still put the teeth in it.
You still put the teeth in it? Is that what they still do in middle school? Maybe I should be a middle school teacher. Then I could do artwork on my inequality signs, put teeth on it. No? All right, so for our triangle inequalities in triangles, we first think about the relationship between sides of an angle. So fill in the following blanks in your notes. The first sentence says, the angle opposite the largest side is the largest angle. And the side opposite the largest angle is the largest side. Which kind of makes sense. If you think about, if I were to make a triangle out of my arms and the distance between my elbows, does everybody see the triangle? Right now, my angle at my hands is acute. If I were to make that angle obtuse, is the distance between my elbows getting larger or smaller than the first? Larger, right? And obtuse is definitely larger than an acute angle. So if we look at this triangle, and you do need to make a change that 5 to a 6, please. That was a bad error on my part. 5, yeah, turn it into a 6. Yeah, because 5 is not going to work out, and I'll get to that in a second. So for this example, we're going to first list the sides from largest to smallest. Now that's pretty obvious since they do have the side measurements there. What's the largest side? AB, 12 units long, so AB is the largest side. Followed by what? BC, and then your smallest side would be, I went with A first, but CA would work also. So it's easy to see largest, smallest sides. Now let's think about angles. Now there aren't degrees in my angles, so I can't just look at numbers and try to find the smallest number and the largest number. So we have to think about the relationship between the largest side, side AB, and the angle opposite of it. Well, if I go to the angle opposite of side AB, that gets me to angle C. So if AB is the largest side, then it would follow suit that angle C would be the largest angle. What would be the next largest angle? Angle A, good. And my smallest angle would be angle B, good. There's a problem like this on your midterm. Some of you will make the mistake by not reading the directions. It may say least to greatest instead of largest to smallest, and you're going to list it as largest to smallest. And the only one you'll get right is the middle one, because the middle one stays the middle all the time. But these will be flip-flopped, and then you'll get it wrong because you didn't read directions correctly. Okay, so don't make that mistake. It's an easy problem, but you could get it wrong by not reading the directions. Questions with any of that? No? Okay. So this leads us to the triangle inequality theorem, which says that the sum, so that means we're adding, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So for a triangle to be able to be made, the triangle inequality theorem needs to work. And I'm going to go back to the original triangle. Give me 2 seconds to finish writing. 3, 2, 1, we're good. And I'll show you why we had to change that 5 to a 6. If we would have left it as a 5, 5 plus 7 makes what? 12. Is 12 greater than 12? No. So that technically, with those three our measurements, would not be able to make a triangle. So I did a poor job of creating my diagram. So when we turned it into a 6, 6 plus 7 is 13. Is 13 greater than 12? Yes. If I do all the other combinations, 7 plus 12 is 19. Is 19 larger than 6? Yes. 6 plus 12 is 18. Is 18 larger than 7? Yes. So these are possible side lengths for a triangle. Okay, so that's how that works. So now, if we go to the next example, now they're giving us two possible side lengths of a triangle, and we need to describe the possible lengths of the third side. Well, possible lengths means it could be a multiple number of possible lengths for that third side. So let's just make a generic triangle. Don't worry about what it looks like right now. Let's say one side is 8 and one side is 12. What would be a possible side length for the third side? Someone just give me a number. Just guess. I don't even care if it's right or wrong.
21.
21. So if we don't write this, just watch. If we would make the third side 21, would that work? 8 plus 12 is 20. Is 20 larger than 21? Nope. 21 would not work. Thank you for throwing that out there because I do well. 19. Would 19 work? Yes.
So anything below those two added
Would 19.9999 work? Yes. Okay, so Cam was continue with what you were saying.
So if like 8 plus 12 equals 20, so anything under 20 for this example would be correct.
All right.
Even if it was 0.999.
So anything under 20 is 3 under 20. Does 3 work? 8 plus 3 is that greater than 12? No, so there is a stopping point. So everything below 20, but there is an ending point. Where is that ending point? Would 5 work? 8 plus 5 is 13. 13 is greater than 12. Would 4 work? Would 4.1 work? Yes. So it's everything between what two numbers for this example? Well, it could be 4.00001, right? Technically. So, but we can go 19.9999. So change your top number, Dawson. So anything between 4 and 20. We're not putting equals to with our inequality signs because we don't want it to equal 4 and we don't want it to equal 20, but we want x to be in between the two. So x needs to be greater than 4, and x also needs to be less than 20. So let's just quickly make a quick note. How do we get that number 4? Where does that come from those two numbers, 8 and 12? What do you do with 8 and 12 to make 4? You subtract, right. So to get the lower number, you subtract your two sides. And then what do you do to get the upper number? Add the two sides. Good. All right. Now I know this is not on our notes. I'm just going to go through, make sure we have this stuck in our brains. So just watch and soak it in. Make sure you got it. If I give you these two sides, let's go 4 and 7. What would be the possible lengths? Lower bound would be 3, upper bound would be 11. Good. If I did 12 and 22, lower bound would be, try again, 10. Upper bound would be, I was going to write 24, 34. Good. If it was 3 and 4, 1 and 7, right? So everybody got this? Yes? Okay, so now, in our next example, instead of just giving you two sides and coming up with a third possible side, they're going to give you all 3 sides, and then you need to decide, could a triangle be constructed? So, check all of your combinations. 6 plus 7 makes what? No, 13. Is 13 greater than 11? Yes. Is 7 plus 11 greater than 6? Yes. Is 6 plus 11 greater than 7? Yes. So since it's a yes for all combinations, we would say yes, it can be possible to construct a triangle with the given side lengths. Okay. If we look at part B, would that one work? No, why not? Right, 3 plus 6 is not greater than 9. So that's enough to say no, it can't be a triangle. It does work with all the other combinations. 6 plus 9 is greater than 3. 9 plus 3 is greater than 6. So those all work, but you just need one wrong for it to be a no. Okay? All right, flip on to the back. I know it's blank. We're going to do some quick practice problems, so you can just doodle your answers there.